Okay, we've got this 253 here. I'll just put the crank in. This crank's been machined and the tunnel's been line bored, the rods of course have been resized. This will have 2 thou clearance on the mains, 2.5 on the big ends. We do a lot of work to the cranks. You can see here how we've scarfed a lot of metal out of the pin area of the crank. That gets the counterweights effectively heavier. Again, we're taking more metal out of here. We clean up a lot of the original machining marks on the crank there, set up datums for the original manufacturer. We clean them up at the back here. Again, you can see we're taking the metal out there. What that does is makes counterweights heavier than they need to be. So when we go to balance it, instead of drilling holes, big holes in the counterweights like they do in the factory, what we do is we turn the entire counterweight down. That reduces the weight of the crank and it gets our balance pretty damn close to where we need to be. That way we only just have to spot it a little bit to get our final, trim our final balance in. So that's in, that's spinning nice, and we'll come back to it when the pistons are in. Okay, this is the piston that we're using. First of all, the rod's all deflashed down the sides here. New ARP rod bolts, resized, shot peened, a little bit of work, radius milled in the top and bottom here to get the weight down. These are the pistons we're using. They're ACL raised top pistons. You can see the dome there. 1.5mm rings, very, very low tension rings, very low friction rings. Good high protective piston, very strong. We have used forged pistons, but you know, a couple of grand just for a set of pistons, it's a lot of resources go into the piston. So I can't imagine an NA application where these things wouldn't stand up. They're a very, very good piston. Lightweight bore pin. They're really, really good piston. Nice and strong, not too heavy. So that coupled with the A9L rod that's been lightened down to about the weight of a standard rod and made a lot stronger. It's a really good, solid combination. Okay, here's the engine. We've got the pistons in now, turning over really nice. It's only taking about 13 or 14 foot-pounds to turn the engine over, which is nothing. That's to do largely with the low tension rings. Also the rear main seal, this is a rope block, but it's we put a neoprene insert, or rubber insert in the housing. It's out of another engine, a Buick, and so you don't get that drag from the rope seal. We use 3 different lubricants when we assemble the engine. We use oil, just engine oil on the pistons, on the rings and pistons themselves. We use an assembly lube, a high zinc assembly lube on the bearings, and then you use the ARP grease on the bolts themselves. And we check them for stretch when we tension them up. It's all clearance. Now this is, I don't know if you're going to see in here, but when I bring the crank around, I don't know if you can see the rod bolt there. It's getting tight on the bore, so you have to relieve the bottom of the bore to get the rod bolt through. That's because we're using the A9L rods. They're a lot beefier rod. You also have a problem down in the back of the bore as well, so that gets clearanced as well. I don't know if you can see in there. So that's all clearanced. What else we got? Cam bearings. We're using the 2 thou undersized cam bearings. The Holden specification seems to be a bit loose for the clearance on the cam bearings. So a couple of manufacturers make cam bearings in 2 thou undersized, so the shell's a little bit tighter than standard. You don't normally have a problem getting the cam in. Sometimes number 4 can be just a tad tight, and you've just got to give it a rub, give the camshaft bearing journal a rub down, just to get it to spin nice. But it's not a problem, and it really does help to hold oil pressure a lot better, having those 2 thou under bearings. Now these pistons, I'll flip it. Oh, just one other thing while it's here. We do a bit of work on the oil system, which I'll show you a bit more later, but we just give a good radius to these oil passages here, just so, a bit like porting ahead, just to allow the fluid to travel nicely as it goes about its travels. I'll just flip it over if I can. There we go. Now these pistons, I'll bring one up, get the spanner on. Alright, these pistons are 0 decked, so you can see there, bring it up. This outer ring of the piston here is the same height as the deck, but this dome sits well and truly above. Try and get down, you can see how much higher that sits above, and that's compression right there. Very hard to make compression on a 253 without scarfing your heads in half. This goes a long way to making compressions. I'll run some calculations to put that in later. The other thing to note here is that obviously we run a tap through all the bolt holes and that sort of thing. Now these pistons haven't been available for a long time. We used to use them a lot back in the day. They haven't been available. I managed to get hold of a set, just some old stock that one of the suppliers had, but they're standard. Now that's not a standard size, but not oversized. That's not a problem because what I've done is I've sleeved the ball back, sleeved all the cylinders back to standard. I've used A-liners, which are good for standard, or they can go out to 30, so you'll actually get another rebuild out of this engine. The sleeves go in, and when they go in we put a square step at the bottom of the parent bore so that the sleeves go in and sit home. They won't move, they never do. A couple other things we've done to the block. We deflash, usually really daggy in here, lots of little bit of metal that can break off and just upset the oil flow, so we de-dag all the block in the valley, also in the back of the valley and around the main caps. I've also honed the lifter bores, give them a clean up hone. You'll see here, and also in the front of the block here, get the lighting. These are normally little press-in plugs, little Welsh plugs, and while it's apart, I just tap it, and so we can put screw-in plugs there. It just saves that worry of the plugs ever coming out. Cam bearings are installed, and they get installed with the oil hole in the 4 o'clock position. That means as the cam's going around, and you've got load this way and that way from the lifters, the cam gets pushed down into the bottom of the bearing. By installing the oil hole here, you can't on number one has to be up on the main gallery, but on the other bearings, putting the oil hole here allows the oil to enter in the high load area of the bearing, so that again can increase your oil pressure a little bit, because up the top where you've got the increased clearance, your oil's not getting bled away there, it's already done its job, so it can bleed away there without a problem, but down in the high pressure area you're feeding it where it needs to be fed. Let's see, what else have we got? These pistons obviously, because they've got this milled out section here, that's to fit the quench area on the head. So these are the left hand side and they're marked left. These are the right hand side and they're marked right. So you've got to put these pistons in left and right in the right size. Given the bore's an extra thou clearance, the minimum clearance on these pistons is fairly tight, 2.5 thou, which is okay if it's Grandma's Statesman that she drives to church on Sundays, but when you're going to pull some numbers out of it, I give it an extra thou. They're not loose in the bore, like there's still a lot of stability in the bore there, so you've got to have the piston stable in the bore, otherwise your rings are going to be flopping around and you're not going to get a good ring seal because your piston's moving, oscillating inside the bore. So I figure 3.5 thou is a good clearance for something like that. I will put main studs in it, I'm just waiting for them to come. And another thing we do to the oil system is where you've got, so the oil pump sits down here and the oil shoots up the gallery here, it changes direction through another drilling there, it then changes direction through another drilling there, and then goes into the main gallery there. So you've got quite a few different changes in direction, and they're just square drillings. And it's a bit hard for fluid to flow around square edges. It's the same principle with your cylinder heads, getting the gas to flow nicely around the corners. So what we do is we get in there, we radius all those inside turns, just to get the oil, just to get the fluid to flow nicely, and that again can just help ensure that you've got a good oil system. This is about all we do with the Holden engines, and we just don't have oil system problems. So that's about it for now, and yeah, thanks for watching.